Today's video will try to memorize the procedure for column chromatography as well as some troubleshooting techniques for TLC plates. So in the column chromatography, but in our lab we're only using a pipette instead of a real column. So when you set up, there should be a cotton at the bottom and there should be some silica in here. So the first step is to prime the silica. That just means passing some eluent, such as 4:1 hexane ethyl acetate. Passing the eluent through the silica gel to wet it, and then stop when you have just around 2 millimeters of your eluent up here. 2 millimeters. Then you can load your sample in, and they recommend around 100 mg, which is around 0.01 grams, but it's better to keep it lower than that number than to overshoot it, because you never want to overload your sample. So this is your sample, and you'll know if you do this right is that your sample is going to keep this visual line at the top, because if you see that your sample no longer is like at the top, you know you've done something wrong, and that's usually with a syringe adapter. Okay, so then you load your unknown sample, and now you want to load your eluent to pass the sample through the silica. So you will use a syringe adapter to push pressure, to push air through, but each time you push your air through, you have to disconnect it again to let the air come back in, and then push it through again. Otherwise, you will, and I've done it, it's awful. You don't want to do that on the lab exam. Otherwise, you will suck the entire thing up a syringe, and you're not going to have this beautiful line of sample at the top, and the proctor's going to know you did something wrong, and they're going to take some marks off. So be careful. So why are you passing eluent through? Because you want to collect your fractions. You want to collect 5 fractions for this lab, 5 fractions, each with around 2 millimeters of fractions. But now, why are we collecting fractions? Because we want to isolate and purify the compound, but we have to know which fraction has the right pure compound that we're looking for. So you will have a TLC plate to try to find out which fraction contains pure compounds. And that's going to be the ones that have only one compound in their lane. Then you combine these compounds and you put it through another TLC plate to compare it with the standards to find the identity of your unknown fraction. And now in the lab manual, they also say put it through reduced pressure evaporation so that your purified fractions, solvent, can evaporate. And personally, I don't do that because it just takes away all the hard work that I've done. But in the lab exam, maybe you want to fake it and pretend like you did it. So maybe reduced pressure evaporation. And now finally, to dispose of everything, you will have to isolate the silica from the glass. So the glass pipette goes into the glass waste bin. And to get the silica out of it, you just need to keep pushing air with a syringe through it so that it's dry, and you can dispose of this in the silica waste bin. Yeah, so that's how you perform column chromatography. My biggest tip is to disconnect your syringe when you push new air through, and to make sure you'll know if you're doing this right if your sample maintains kind of a nice colored line at the very top. That's how you know you're doing this right. Remember, don't overload your sample. Better a little bit less than 0.01 grams than too much. And you're collecting the fractions, trying to find which fractions are pure, and then comparing that with the standards to find identity. Now I want to talk about troubleshooting TLC plates, because YouTube videos talk about how to do it, great, but they don't talk about troubleshooting. So if your spot is too close to the baseline, that means to solve this, you need to increase the polarity of your eluent. I know it sounds counterintuitive, but that's what the lab manual says. So If you see a large spot or a large smear very close to the solvent front, or aka the RF value is too high, you need to decrease the polarity of your eluent. And this usually happens if you leave your lid off for too long, so that the hexane, which is responsible for reducing the polarity, evaporates, and that's why you have a solution of more polar ethyl acetate instead of hexane. What if you have one huge spot? That's because you need to spot smaller. When you're putting your sample on the baseline, spot it smaller so you have a smaller spot. And if you have a long tail, you need to dilute significantly. So anytime you have a solid sample or a liquid sample, you always want to dilute it in some DCM, dichloromethane, usually around 5 to 10 drops. Safer to go on the high end here so that you don't get this long tail. So yeah, that's all I have about these two topics. However, I do want to note that just for our course, Chem 261's TLC plate, in terms of the column chromatography, here they actually used 3-to-1 hexane ethyl acetate. So I guess that's just something to keep in mind.